Our process begins with the reception of raw materials such as silica sand, to which the following tests are performed for its release and subsequent use in the process: granulometry, grain shape, acidic demand. Once released by the laboratory of sand, it is stored, and when required by the foundry area, it is added into the hopper of new sand to be integrated to the molding process. When the bronze and aluminum ingots reach the plant, a sample of each batch is tested for conductivity and chemical analysis to ensure they comply with our specification. Once verified the above, the quality control area releases the material for the warehouse to supply it to the foundry area when required. The molding process begins with the preparation of the sand, for which we have a speed muller type mixing mill, to which the load of water sand aditrol is automatically added and then mixed for 120 seconds in order to give the sand the required moldability properties. Once the mixture has been prepared, it is automatically downloaded by the mill, and through a conveyor system, the sand is sent to the molding lines. Every 2 hours, the physical properties of the molding sand are checked in the laboratory in order to keep compactness, moisture, compression and green resistance, permeability, total and active clay, and the size grain or AFS under control. Another important process is heart making, for which we have 4 machines, 2 of which are electric and 2 gas-powered. In this process, we use resin-coated silica sand for shell process. The size of the hard boxes vary from 6.5 by 3.5 inches to 23 by 7.5 inches, at a cycle time of 90 seconds per cycle. The temperature of these hard boxes goes from 220 to 270 degrees Celsius, and the curing time is 60 to 120 seconds, depending on the size and shape of the heart. For parts cleaning, we have 2 blasting machines. Once the sand and hearts are prepared, the process comes to the manufacturing of molds, for which we have a semi-automatic FBO model Sinto machine, with a nominal capacity of 100 molds per hour and a size of plates used for molding up to 14 by 19 inches. This machine blows and compacts the sand automatically, yielding an upper mold and a lower mold on which in the shape of the piece to be produced is stamped. If our final product has cavities or holes, the hearts are placed in the shape of these. This equipment also produces parts that require no heart. Once the hearts are placed, if the part requires it, the mold is blown and inspected to remove small particles of loose sand and to verify that the print is a faithful replica of the model plate. The mold is closed and transported to the emptying and cooling carousel automatically. While the molds are made into the Sinto machine, the metal is melted and prepared. For this, we have 2 induction furnaces for bronze melting, with a capacity of 160 and 180 kilograms of molten bronze, and 2 electric-resistant furnaces for melting aluminum, with a capacity of 800 and 200 kilograms of molten aluminum. For the preparation of the load, 60% of the ingot is used and 40% is returned. The melting cycle in induction furnaces takes from 28 to 30 minutes to melt 160 to 180 kilograms of bronze, and the electrical resistant furnaces takes 3 hours to melt 100 kilograms of aluminum. The working temperature goes from 1200 to 1300 degrees Celsius for bronze and from 680 to 750 degrees Celsius for aluminum. Once the mold is ready and the metal prepared, which temperature and chemical composition must be within specification and free from slag, it goes on to be poured into the molds that are moving in the casting and cooling carousel. To improve the quality and mechanical properties of the aluminum parts, we have some degassing equipment by which argon is injected into molten aluminum to remove the hydrogen dissolved in the molten metal and to minimize gas porosity in the parts made of this metal. 30 to 35 minutes after the pouring into the molds, they come to the demolding area, where by means of a sakeout, the trunk with the parts, piece plus cast, is separated from the sand as this is recovered through a system of bands in a 60-ton silo for reuse in the molding process. Once cool, the trunk, piece plus cast, passes to the blast and/or cut area. If they are small parts with sharp edges, they are cut first and then blasted. And if there are pieces that have no raised edges or large size, they are blasted first and then cut. For blasting, we have two Wellbrader blasting machines that use steel blast for the cleaning of material. For cutting, we have 4 band saws. Once cut and sand-free, the parts pass to the grinding process, which eliminates excess material at the pouring of the metal to the part and parting line, for which we have 4 double-header pedestal grinders. Later, the parts are 100% inspected to separate those that do not meet the customer requirements. These are recorded and returned to the fusion area. Once grinded and inspected, the good parts are blasted again to give the material a single finishing tone. Then they are counted to meet the amount requested by the work order and place a release sheet with records that each piece meets the quality and quantity requirements. The part is ready to move to the machining area. We also have an area for manual molding where we have 7 Jot squeezer type machines, with a capacity of 11 molds per hour per machine. An operator per machine is required, and the size of the pattern plates to use for the manufacture of the parts ranges from 12 by 12 inches to 12 by 18 inches. The plates, which dimensions are larger than 12 by 18 inch, are molded into floor, same as the large master models for parts of substation. In the metal fusion area, we have 1 induction furnace with a 200 kilowatt power unit and 2 push-out type fusion stations using graphite crucibles with a capacity of up to 120 pounds of cast bronze and a cycle time of 30 minutes per batch. And 2 electric resistant furnaces for melting aluminum with a capacity of 200 kilograms of molten aluminum and a cycle time of 100 kilograms of molten aluminum every 3 hours. The secondary process is composed of different threads, which are: this is where all the products coming from the primary process in different operations are processed: grinding, drilling, threading, roll turning, washing, and assembly. All operations are carried out complying with the specifications of the plan, following the rigorous quality specification that our customers deserve. After completing the machining operation, the material is placed in the area called whip, where the sets of parts are put together, along with the hardware to then be released. Then they go to the assembly area, where one of the last tasks of the process is carried out. There, the products are assembled. packaged, and labeled to be admitted to the finished goods warehouse. After that, the product capture in the system takes place to then proceed to the billing and delivery to the facilities of our customers. The inspection of the products is given at all stages of the process. The whole process of this product follows the plan established under the work order being manufactured. The process begins with cutting the copper tubing for the manufacture of the splints that are the ends of the connector as finished product. This tube goes then to an external process, whether washing, stripping, tinning, or special processes such as plated coating. After that, it comes back to the production floor and the braid is cut, which is inserted into the tubes after these have been crushed before. Then it is given dimension and finished making the manual crush, hydraulic crush, ferrule crush, sanded, packaging marking, and inspection. After that, it is entered to the warehouse and delivered to the customer. The extruded area has three families: YPC, YP, H frames. 95% of the production of this area is for export. The process begins with the cut of aluminum profile, which is supplied by the raw material warehouse, using as control a work order that goes with it throughout the process. The material, after being cut, goes to the washing room where it is processed by removing excess cutting edges and applied an antioxidant. The next step is stamping, turning to the implementation of Penetrox, and after bagging and packing, it finally goes through the releasing process, which takes place under the most strict quality standards establishing throughout the manufacturing cycle for our products.